Okay, this is Math 105, section 1.5, and we're going to talk about solving equations in this section, starting with linear equations. So when we talk about solutions or roots to an equation, those basically mean the same thing. We're finding the values of the variable, the unknown, that make the equation true, okay? And this process is called solving the equation. So basically we're trying to get, x equals 2 or something like that, okay? So we do that by using a series of equivalent equations, okay? And think of those as those are our steps in solving, okay? So equivalent equations are two equations with exactly the same solutions. So basically what we're doing is we're going to get a series of equivalent equations that get us towards our solution. And let's say our solution is x equals 2. That would be our last equivalent equation, okay? So the idea is that every time we get another equivalent equation, we're getting closer to our answer. We're simplifying it a little more, okay? Okay, so to solve an equation, we try to find a simpler equivalent equation, okay, where the variable is by itself, okay? Yeah, so ultimately we're trying to get the variable by itself. Okay, so here are some of the things that you can do to solve an equation. We say A, B, and C stand for any algebraic expression, and this means equivalent. So these are the same thing. So if you have A equal to B, some expression equal to another expression, we can add the same thing to both sides and we still have equality, okay? So adding the same quantity to both sides of an equation gives an equivalent equation. So we can add the same thing to both sides, and by that property we can also subtract the same thing on both sides, okay? When we have two expressions that are equal, we have an equation, we can multiply the same thing on both sides. C times A equals C times B, as long as C is not equal to 0. So multiplying both sides of an equation by the same non-zero quantity gives an equivalent equation. So that means we could also divide on both sides, right? Because division is just the opposite of multiplication. Multiplying by 2 on both sides is the same as dividing by 1/2, right? So we can add or subtract on both sides. We can multiply, divide on both sides, as long as it's not 0. Okay, so a linear equation is in this form: ax plus b equals 0. We're not using y yet, we're just using one variable. Okay, so a and b are real numbers and x is our variable. So ax plus b equals 0 is the form of our first linear equation that we'll use. Basically, you're not going to have x squared or x cubed. It'll be just x. Okay, that's the idea of linear equation, is that we just have something times x plus something else equals 0. So here's some examples of linear equations. 4x minus 5 equals 3. If we had going to get 0 on one side, we could subtract 3 on both sides. 2x equals 1/2 x minus 7. Here we could get x and the number on the other side, so we would get 0 on one side. But notice we just have x here. We don't have x squared. Okay. This is also a linear equation. It might not look like it because of the divide by 3, but this is the same thing as 1/3 x over 3. So we could say x minus 6 equals 1/3 x is also a linear equation. We can get 0 on one side, and we're just going to have something times x here. Okay, these are nonlinear equations. When we have x squared, okay, that's called a quadratic. Okay, that is a polynomial as well, right? It has a degree of 2. Okay, this is not linear because that square root x. Now that's not a polynomial because we have x to the 1/2 there. Okay. And then this is not linear because we're saying 3 divided by x. Now that's x to the minus 1, right? So this would not be linear either. Okay, okay, so let's start with this example. This is a linear equation. 7x minus 4 equals 3x plus 8. Now we want to get x by itself. That's our goal, right? So we can start by, let's say we're going to keep x on this side. We can start by adding 4 to both sides. So we get rid of the minus 4 here. So that's what we do first. Okay, so this cancels the minus 4 here, and then it gives us a plus 12 here. Okay, and then the next step is, now we have 7x equals 3x plus 12. Okay, now I want to get the x out of this side because I just want it on the left-hand side. So I'm going to subtract 3x on this side, and I'm also going to do it on this side. So make sure you do it on both sides. Okay, and when you subtract the 3x on this side, it cancels the 3x. And then here we get 7x minus 3x like terms. We get 4x. So now we have 4x equals 12. Okay, and we can multiply. Now we want to get x by itself, right? So we can multiply by 1/4 on both sides to get x, or we can say divide by 4, same thing. Okay, so when we multiply by 1/4 or divide by 4 on both sides, we get 1/4 times 4x is x, and then 1/4 times 12 is 3. So these are our equivalent equations. We had the first one, then we had this one, then this one, then this one, right? So there's our solution, x equals 3. But we're getting a series of these equivalent equations to get our solution. And then our last step is just to check our solution. So here's our original equation, 7x minus 4 equals 3x plus 8. And we're going to plug in our solution, x equals 3, into each side. So 7 times 3 minus 4, and then 3 times 3 plus 8. 7 times 3 is 21, minus 4 is 17. And then 3 times 3 is 9, plus 8 is 17. So we see that the left-hand side equals the right-hand side. That's what the LHS stands for, is left-hand side. RHS is right-hand side. So we see that those are equal, and that shows that our solution is true. Okay, now we're going to look at how we solve quadratic equations. We've already looked at linear equations, and those are first-degree equations. Okay, so linear equations are first-degree polynomials, okay, like 2x plus 1 equals 5, or 4 minus 3x equals 2. Quadratic equations are second degree. Their highest power of x is 2. So we're going to have an x squared in it, like x squared plus 2x minus 3 equals 0, or 2x squared plus 3 equals 5x. Okay, so a quadratic equation is an equation of the form ax squared plus bx plus c equals 0. Okay, where a, b, and c are real numbers, and a is not equal to 0. Okay, now that's important because we want to make sure that we have that x squared term. Okay, to make it, what makes it a quadratic equation is that x squared term. These are optional. You don't have to have the bx or the c, but you definitely have to have the x squared to have a quadratic equation. Okay. Now that means if we can factor the left-hand side of a quadratic equation, then we can solve it by setting each factor equal to 0. Okay. Now this method works only when the right-hand side is 0. So that's important that we have, that right-hand side of the equation is equal to 0. Okay. So make sure that we have 0 on one side when we do this. Okay, so let's say we're trying to solve the equation x squared plus 5x equals 24. Now we're not going to factor this yet because we want to get 0 on one side, so we're going to move that 24 over first. Okay, so we're going to rewrite the equation so that the right-hand side is 0. So we're subtract 24 on both sides, and we get x squared plus 5x minus 24 equals 0. Now we can factor because we want that 0 product property. So if we factor this thing, we have two things multiplied equal to 0, which means we can set either one of those factors equal to 0. So remember how we factor this quadratic, once we have 0 on one side, is we do FOIL backwards. So we want the first two to multiply to x squared, so we use x and x. We want the last two to multiply to minus 24, okay? And then we test our outside inside to see if they add up to the middle term. So we have 8x minus 3x, and that gives us 5x. So that works. Okay, so those are our factors. Okay, so we take each factor and set them equal to 0. So we had two factors, x minus 3 times x plus 8, right? So we could say x minus 3 equals 0, gives us x equals 3, or x plus 8 equals 0, gives us x equals minus 8. Okay, so we have two solutions, x equals 3, x equals minus 8. Check our answers. So we were doing x squared plus 5x equals 24. Okay, so that was our original equation, was x squared plus 5x equals 24. So that's what we're plugging in here with our two solutions. Okay, so when you plug in 3, you get 3 squared plus 5 times 3, which is 9, plus 15, which is 24. Check, that works. And then try minus 8. So minus 8 squared, remember that's minus 8 times minus 8, so that's 64. Okay, Plus 5 times minus 8 is minus 40. So 64 minus 40 is 24. That works as well. Okay, so that's how we check our solutions, is we plug in our answers to the original equation. Okay, and we're solving a simple quadratic equation. That's this form. We have x squared equals some number. So when we have x squared equals c, we can use x equals square root of c and x equals minus square root of c. Okay, so for example, here we have x squared equals 3. What we can do is say x equals square root of 3 and x equals minus square root of 3. Okay. Now, the way we solve this is what we're doing with the simple quadratic equation is we're just taking the square root of both sides. Okay, so we have x squared equals 3. We can take the square root of both sides, but when you do that, make sure you put a plus or minus in front of that square root of the 3. Okay, the reason for that is because when you take a square root of something, you're only looking at the positive, but if you take a negative and you square it, you can get a positive as well. So we're kind of taking that into account. So square root of x squared is x, and then this is plus square root of 3, and then minus square root of 3. Okay. So whenever you can take the square root of both sides of an equation, but make sure you put a plus or minus on one side. Okay, so let's look at a couple examples. Here we have x squared equals 5, and basically we're just going to take the square root of both sides, right? And if you do that, you get x equals plus or minus square root of 5. But we can also follow the principle from the previous slide. Okay. With this one, now we don't have x by itself in the square, but we can still take the square root of both sides. Okay. So what you can do with this one is you can take the square root of both sides, okay, and just make sure you put the plus or minus in front of that square root of 5. So now we have, since we're taking the square root of x minus 4 squared, this will give us x minus 4 equals plus or minus square root of 5. Okay, and then we can just add 4 to both sides. So that gives us x equals 4 plus or minus square root of 5. So we get two solutions. One of those is 4 plus the square root of 5, and one is 4 minus the square root of 5. So we can still use that same principle, even when we have like an x minus 4 in the square. Because we can still, if we have a perfect square, we can take the square root of both sides, and it undoes that square. That's what the square root does. It undoes the square. So here we can see that x minus 4 equals plus or minus square root of 5, and then we just add 4 to both sides. Okay, so here are our two solutions. X equals 4 plus the square root of 5, and x equals 4 minus the square root of 5. Okay, so just to summarize what we did earlier, if a quadratic equation is of the form x plus a or x minus a squared equals c, in other words, we have a perfect square on one side, then we can solve it by taking the square root of each side, okay? Because you have this perfect square here, right? And we just take the square root, it eliminates the square there, okay? We say the left-hand side is a perfect square, okay? If it doesn't factor easily, so if we can't factor, so if a quadratic equation does not factor readily, then we'll use what's called completing the square. So we'll look at that next. Okay, so completing the square, what we're looking for is we're trying to make a perfect square on one side. So, for example, let's say we have x squared minus 6x on one side. Okay, it's not a perfect square. Now we can factor that. If we have 0 on the other side, we could do that, and that would work. But if we don't, we can't do that. So what we can do is we can take, what we're doing is we're taking half of this x coefficient, this minus 6, and squaring it and adding it. So we're going to add minus 3 squared, which means we add a 9. Now that gives us a perfect square, okay? So that's what we do is we start with this thing and we want to make it a perfect square, so we're going to add 9 to that. So we're going to add minus 3 squared, okay, to make it a perfect square. So the idea for completing the square is to make x squared plus bx a perfect square. We take half of our b, or b over 2, and square it. Square of half the coefficient of x, okay, which is our b. And this gives a perfect square. So we could say x squared plus bx plus b over 2 squared equals x plus b over 2 squared. So that this part is what makes it a perfect square, is taking that b, dividing it by 2, and squaring it, okay? Like here, our b is minus 6, so we're going to say minus 3 squared is 9, and that gives us x minus 3 squared as a perfect square. So that's the idea. So this takes practice, and the important thing is that we recognize how to make a perfect square out of something like x squared plus bx or x squared minus 6x. Okay, so let's look at this first example. X squared minus 8x plus 13 equals 0. We can't factor this, okay, using FOIL and reverse. So we say that that's a prime quadratic because we can't factor it. Okay, so the first thing we want to do is let's ignore the 13 because it kind of gets in our way. So let's move it to the other side. We're going to subtract 13 on both sides. So now we're just going to focus on the x squared minus 8x. And we're going to take half of that minus 8 and square it. So half of minus 8 is minus 4, and when you square that you get a plus 16. So we're going to add a 16. Now that gives us a perfect square here, but you have to make sure that you do the same thing to the other side. Okay, so we're taking minus 8 divided by 2, which is minus 4, squaring it and adding it to both sides. Okay, and that gives us this equation, x squared minus 8x plus 16 equals 3. Because we took 16 minus 13 on the other side from the previous slide. This is our perfect square. This factors to x minus 4 squared. Now, you can also say that, you know, what we're looking at is half of this to go here, right? X minus 4 squared, you take half of that minus 8 to get the minus 4 there. Okay, so this gives us our perfect square. Now, we can take the square root of both sides to solve that. And we make sure you put a plus or minus in front of that square root of 3. And then that cancels this x minus 4 squared, the square root, and that's how we get x minus 4 equals plus or minus square root of 3. And then we just add 4 to both sides to get our solutions. X equals 4 plus the square root of 3, and x equals 4 minus the square root of 3. So those are our two solutions. We can do this with any quadratic. Okay, so for our next example, we have this one. 3x squared minus 12x plus 6 equals 0. Now, we can only do this completing the square when we have a 1 on the x squared, and here we don't have a 1 on the x squared, so we have to take care of that. But let's start by moving the 6 over, because that's going to get in our way. So we're going to subtract 6 on both sides. Okay. Now we have to factor out that 3, because we can't have a 3 on the x squared. We can only have a 1 on the x squared. So we're going to factor out a 3, or we could divide both sides by 3, and notice that would, you know, divide from the minus 6 as well. Okay, so what we have is this. Let me write that down after we divide the 3. X squared minus 4x equals a minus 2. So we're dividing by 3 on both sides. Okay, so now we have x squared minus 4x equals a minus 2. We divided both sides by 3 to get that, right? And we want to make this a perfect square, so we're going to take half that minus 4 and square it and add it, and then add the same thing to the other side. Okay, so this gives us a perfect square. We have this x squared minus 4x plus 4 is just x minus 2 quantity squared, and then minus 2 plus 4 is plus 2. Okay, now we can take the square root of both sides. Okay, make sure you use a plus or minus in front of that square root of 2. Okay, and that gives us x minus 2 equals plus or minus square root of 2, and then we're going to add 2 to both sides here, okay, to get x by itself. So there's our two solutions for that quadratic.